it will reach that certain height and come back to the ground. Same initial position. Since it is coming to rest, final velocity is 0. S2 minus S1 divided by t square. It covers a distance of 200 meters. Hello students, this is SD Sir, yet again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. A new chapter, a new session. Today we will be working out problems from the chapter Motion in a Straight Line. Chapter from the unit Mechanics. Dear students, solving problems from mechanics needs skill, needs aptitude. So now we focus on problems from motion in one dimension. The first one. The first problem says, a car is moving in a straight highway. A car is moving in a straight highway with a speed of 35 meters per second. So the car is moving with some initial speed. It is moving with a speed of 35 meters per second and is brought to stop. The moment I say it is brought to stop means it is brought to rest, covering a distance of 200 meters. So the car, which is traveling with a speed of 35 meters per second, is brought to rest. And on doing so, it covers a distance of 200 meters. I have to calculate its retardation and how long does it take for the car to stop. When I say how long, it is the time taken by the car to stop. Now, just picking up the data, the car is moving with a speed of 35 meters per second. So the initial speed of the car is 35 meters per second. And it is brought to rest. The moment I say brought to rest, it means the final velocity of the car is 0, covering a distance of 200 meters. With this data given, I have to first calculate the retardation, where retardation is nothing but negative acceleration. So if you observe the data, there is no parameter called time given. No information about time is given. So which equation of motion do I consider here to calculate acceleration, which should be independent of time? The third one. So we say, now v square is u square plus 2a. Yes. See the equation of motion which is independent of time. V0 equals 35 square plus 200. So now 35 square. So on substitution, this becomes 400A, or A is equal to minus 3.06 meter per second square. So very clearly you can see acceleration is having a negative sign, which shows it is retardation. Now, the first part of the problem is calculated. The next part, how long will it take to stop? Now, I use V equals U plus AT. U is 35 plus A is minus 3.06. T minus 35 is minus, gets cancelled. Now simple simplification. T is 35 divided by 3.06, which is nearly 11.43 seconds. So very clearly, I have used two equations of motion and solved the given problem. The next one, a car starts from rest, which means its initial velocity is 0. So a car starts from rest. Its initial velocity is 0 and accelerates uniformly for 10 seconds. It accelerates uniformly for 10 seconds with a velocity of 36 kilometers per hour. It is starting from rest. Initial velocity is 0 and accelerates for 10 seconds with a velocity of 36 kilometers per hour. It then runs at a constant velocity and is finally brought to rest in 50 meters with uniform retardation. If the total distance traveled by the car is 500 meters, find the acceleration and the retardation. Now, V is 36 kilometer per hour. Now, if you look at the unit, it is kilometer per hour. But the SI unit is meter per second. So, convert this 36 into 1000 divided by 60 into 60. So, converting kilometer per hour to meter per second, 36 into 1000 divided by 60 into 60, which is 10 meter per second. These are simple calculations. You have your simple calculators. Just substitute and simplify. Now, the first part of the problem, I have been asked to calculate the acceleration. So, very clearly, A is V minus U divided by T. So, this is A. V is 10 minus 0 by 10, 1 meter per second square. So the acceleration gained is 1 meter per second square. Now in the second case, it is traveling a distance of 50 meters before coming to rest. Now I take the initial velocity is 10 meters per second. Since it is coming to rest, final velocity is 0. Now the acceleration in this case, again V square is U square plus 2AS. 0 square is 10 square plus 2 into 50. So this is minus 100, 100A, or A is minus 1 meter per second square. Again, I have arrived at the retardation value. Again, just by using the equations of motion, I have simplified the given numerical. Next one. A body traveling with uniform acceleration travels a distance of 100 meters in the first 5 seconds and 200 meters in the next 5 seconds. So distance of 100 meters in the first 5 seconds and 200 meters in the next 5 seconds. Students, such type of motion is called motion in successive intervals of time. First 100 meters in first 5 seconds. Next 100 meters in next 5 seconds. That is what we call motion in successive intervals of time. Now, I have to calculate the initial velocity and acceleration of the body. The acceleration of any body exhibiting successive interval motion, please do keep in mind, is given by S2 minus S1 divided by t square. So this is the expression for acceleration of a body which is exhibiting motion in successive intervals of time. Or A is 200 minus 100, 5 square, 100 by 25, which is 4 meter per second square. Next, I have to calculate the initial velocity of the body, for which I refer the equation ut plus half at square. Now, what is S here? First 100 meters, then 200 meters. So, the actual distance traveled is 100. U 5 simple simplification. So 100 is 5u plus 2 times 25 into 2. So u is, so this is 50 is 5u, or u is 10 meter per second. Again, very simple simplifications. An assignment problem for you all. A stone is thrown vertically upwards with an initial velocity of 19.6 meter per second. After how long will the stone strike the ground? So a stone is thrown vertically upwards with a velocity of 19.6 meter per second. So u is 19.6 meter per second. Now, what is the actual displacement of this stone? It will reach that certain height and come back to the ground. Same initial position. So, S is 0. Why? Displacement is 0 because it is reaching back the same initial position. And since the action is against gravity, I say A is minus G, which is minus 9.8 meter per second square, from which I have to calculate T. I want the time factor here. So I use S equals UT plus half GT square, or plus half we have, on simplification, form a quadratic equation, solve. T appears to be 4 seconds. So in my today's session, students, I have used the equations of motion and I have solved few numericals. Next session, I will solve few more numericals from motion in a straight line. Until then, have a nice time. Thank you.